Okay, for this question we have to explain how a graph of velocity against time can be used to find the acceleration and the distance traveled of a object moving with a constant rate of acceleration, i.e. linear motion and constant rate of acceleration. So let's start with the acceleration. So for these graphs, the acceleration is equal to the slope, also called the gradient, which in this case, if we were to think of this as a coordinate geometry problem, that's the point TV, and then this is the point 0u. So the slope is y2 minus y1 over x2 minus x1, which is v minus u over t minus 0, which is just v minus u over t. So that's not particularly surprising, because note that's actually equal to the change in velocity over the time elapsed, which actually is a definition of acceleration. So not exactly an outrageous statement here. Next, the distance or displacement. In this case it's the same thing because everything is positive. The distance traveled should equal the area under the graph. Now in this particular case you've got a rectangle and a triangle. So the rectangle is the base by the height, so that's t times u, plus the triangle is a half the base, that's a half times t, multiplied by the height, which is v minus u here. So that would be ut plus a half t v minus u. Now v minus u is actually a t, because what you can say on the side here, you've just shown that a equals v minus u over t, so that implies that at equals v minus u. Okay, so that would be ut plus a half at squared. So again, nothing too surprising here. We're getting our usual formulas for situations where we have objects starting at u, accelerating with a uniform acceleration of a, and ending their journey after t seconds at a velocity of v. And that answers this question here.